expressions, we're basically kind of doing the same thing we just did. The only slight difference, think about mixed expressions, is kind of just a version of a mixed number. Now, we're going to be doing it with algebra. I'm starting with a regular mixed number. Don't get too excited. This is not what we're doing. This is just an example to show you that you already know this. I just want to show you, as an example, if it's a whole number and a fraction, we could write it like this, right? 2 3/4 would be like 2 plus 3/4 added onto it, okay? If I wanted to turn this into an improper fraction, and I'm just showing you it with this number because I think everybody will understand it this way because you know this, and then we're going to add this, apply this strategy to the same thing with algebra fractions. If I wanted to add these together, since I need to have the same denominator, I could put 2 over 1, right? And I could turn the 2 over 1 into a fraction that has a 4 as a denominator. I'm just going to write it off to the side. You can choose to write this or not. I think everybody knows this. I would turn it into a denominator of 4 by going, oh, times 4 and times 4, and I'd get 8/4 plus 3/4 equals 11/4. Now, if we were really working with a mixed number and turning it into an improper fraction, you'd probably just use the shortcut. 2 times 4 is 8 plus 3 is 11, 11/4. I'm showing you this way because this is more of what we're going to be doing with the problems I show you. What you're going to have is a denominator on one number and a whole number on the other side. So just like we did with this whole number 2, when you have a whole number, you're going to put it over 1. And then all you're going to do, you only have to convert one fraction this time. The one that was a whole number with a denominator of 1, you'll have to turn into the LCD. And the easy part here is the LCD is the other denominator. Let me show you what I mean, because that may not be clear how that applies. Let's say, we'll start simple, C, there's my whole number. Of course, it's a variable, because this is algebra, so we'll make it not too simple. C over 5 plus C. Here's my whole number. What do we do with a whole number? We put it over 1. So again, this should be easier than yesterday because all I have to do is make this whole number have the denominator of this second fraction. So guess what? The LCD every time, you don't have to do any work to figure it out. It's the second fraction's denominator. I don't need to change this one. I just want to change the first one so that it has the same denominator and I can add them together. So the only one I'm ever going to need to change is the first one. If I take C over 1 and I want to turn that one into a denominator of C, you think, well, what did I do? Well, I must have multiplied times C. What's 1 times C? 1C. There it is. So all you're really doing is you're multiplying by that other denominator. C times C on the numerator, and I get C squared. I'm now going to use this one instead of over 1. So I have C squared plus C, that's my first fraction, plus the second one. Or sometimes, again, it might be minus. Okay, if my denominator was C, my denominator is still C. C squared plus 5, C squared plus 5. I can't factor that one. I can't simplify the C's because of the addition sign that's happening. So again, this should be actually one level easier. I've been talking about how hard it is. It's like we're climbing up the mountain of difficulty and we peaked yesterday. And now we're on the down slope. We're still high up at the peak of difficulty, but we're on the down slope. This should be a little bit simpler. Let's try another one. 5. Now we'll do a minus one. X minus 3 over x plus 2. Okay, I've got my whole number. Now the whole number in both of these has come first. It could come second. It doesn't matter which position it's in, first or second. No matter what, you take your whole number. And in the last case, remember the whole number was even a variable. We don't even know what that was. In this case, it's an actual number. We put it over 1. What's my LCD going to be? Carissa?
X plus 2.
Yep, x plus 2, the second fraction that has a denominator, or the one that has a denominator, it might come first. That's my LCD. I take that first fraction, 5/1, and I want to turn it in to that denominator. Every single time it's going to look like this, where you have a 1, which means every single time you're going to multiply just by that denominator that you want it to be, because 1 times this thing makes this thing that we want it to be. So you don't even have to figure out, oh, what's missing? There's nothing missing. Every single time you multiply it by that LCD. Now I'll go ahead and distribute here. 5 times x plus 2 is going to be 5x plus 10. Now this one came first. This was from my 5/1, right? So I'm just going to keep this one here first, and right next to it, because it's a minus, and I know I need to be careful with the subtraction problems, I'm just going to write the second one next to it. They've got the same denominator now. Right? So again, you only have to change that one fraction. Because it's subtraction, I go carefully. I say, okay, let me add the opposite of each of these. Now, if you want to rewrite them all before you combine them, you can. I'm going to go ahead and just kind of do it looking at it here. I've got 5x plus negative 1x. 5 plus negative 1 is 4x. I've got 10 plus positive 3, which makes 13. As always, we need to look at it and see if we can factor. If we can factor, we need to try it, because that might help us to simplify. 4 and 13, though, in this case, don't have any common factors. I can't simplify. I can't factor, therefore I can't simplify, so I'm done. Seem easier than yesterday? Yeah. Okay. Can we do one more just to make sure? Yeah. Okay, last one. Okay. All right, let's just flip-flop it, and we'll put the whole number second instead of first. Notice also for these, the denominators, for the most part, the ones I'm going to give you, you don't even need to factor them. They're already just a binomial, so not trinomials, not difference of two perfect squares, so no factoring either for this. All right, I put my 5/1. LCD, Kate? Yep, it's the denominator of whichever fraction has a non-1 denominator, the fraction version. So I take again my 5/1, just a coincidence that it's also a 5 like the last problem. You will see other numbers. Every single time though, all we have to do is take that 1 and multiply it by this LCD that we want to have. 5 times x minus 1 makes 5x minus 5. Now because this one came second in this problem, and it's subtraction, I'm going to spend a minute to just rewrite everything so that I can not miss a sign. I've got x over x minus 1, that came first, minus, now here's my new fraction, 5x minus 5 over x minus 1. For something like this, it's going to be worth it to just take a few seconds to write it down so that it's neat, so you don't miss any signs. Now, because it's subtraction, again, I'm going to add the opposite of that whole second numerator. I just flipped my signs there. You can't really see it anymore because I did it in the same color. So it was minus 5x minus 5. It's now negative 5x plus 5. And again, you could rewrite it all and then combine like terms, or if you think you can combine like terms just by looking at it, let's try it that way. 1x minus 5x, negative 4x, plus 5. Is there anything I can I factor? Let me say that first. Can I factor anything? Nope. Since I can't factor, I can't simplify. Done.